Hi everyone, hope everybody are very good. Today let us discuss about one more topic called as sets. This is there in 10th class in SSE, it is there in 11th class in Cbse. This is helpful to understand relations as well as functions. If you know sets well, then you can understand relations and also functions. Let us see what is a set. A set is a well-defined collection of elements. What is a set? It is a well-defined collection of elements. So, a well-defined collection of elements is called a set. Okay, but we have to know what is well-defined. Collection means what? All the elements together if you take, that is what collection, but every collection is not a set. Well-defined collection of elements is a set. Here in this topic, well-defined means if collection satisfied two conditions, that is in that one condition is every element of collection should have every element of collection should have a common property, should have a common property. First condition, every element of that collection should have a common property, and the second condition, it should be able to decide element is element belongs to collection or not. These two conditions are satisfied, we can say that that collection is a well defined collection, and if it is a well defined collection, you can say that it is a set. So let's see some more examples to understand which collections are well defined, which collections are not well defined. For example, let's take the students of class 10 in a school. The students of class 10 in a school. So in this example, if you they all the students of that collection are having one common property, that they are the students of class 10. That is a common property there. They are the students of class 10. That is the common property. First point is satisfied. What is the second condition? We should be able to decide whether element is belonging to the collection or not. How do we decide? If you take any student, you can decide whether he is of class 10 or not. If he is class 10, he will be belonging to that collection, otherwise he is not belonging to the collection. So we are able to decide whether student is belonging to the collection or not, or whether that element is belonging to the collection or not. So we can say that that collection is a well defined collection and it is a set. One more example, colors of rainbow, colors in rainbow. So here also, what are the colors in the formation of rainbow? We have VIBGR, violet, indigo, orange, red, green, blue. Like this, we have colors. So if you take any color, they all these colors are having one common property, that they are the colors of rainbow, and you are able to decide whether when you take any color, whether that color is belonging to the collection or not. For example, if you take red, yes, red is belonging to the collection. For example, if you take purple, purple is not there in that collection. So you are able to decide whether color is belonging to the collection or not. So this collection also, we can say that it is a well defined collection. Then which collections are not well defined? For example, if you take most talented students in your class, the most talented students in your class, here also it is a collection, but in this collection we are not specifying on what base the talent we are deciding. Most talented means what? Some people will be very good talented, very much talented in academics. Some people will be good, very good talented in sports. So based on what we are defining, the talent is not defined well, so that there they have one common property, but we will not be able to decide which student will come into that collection and which will not, who will come to that collection or who will not come to that collection, we cannot decide. So that is not a well defined collection. Hope you all understood. Whenever most or specifically if it is not decided or defined, we say that it is not a well defined collection. So here I hope you all understood, well defined collection of elements or objects is called a set. And how do we denote this set? A is set is denoted by capital letters, and all the elements of set will be written within the brackets, within the brackets, and those brackets are flower brackets, within the flower brackets. So this is what representation of sets. For example, let's take, just now we have seen uh, vowels in English alphabet. For example, if you take set of vowels in English alphabet, we can denote it as V is equal to A, E, I, O, U. Okay, this is what representation of a set, and this type of representation of a set we call it as roster form. What type of representation it is? This is called roster form of representation. In roster form of representation, what we do, all the elements of the set will be written within the flower brackets and they will be separated by commas. So we can see directly what are the elements in roster form. Then what is the other way of representation? Other way of representation is set builder form. In that form, what we do, uh, the common property, just now we have seen all the elements of collection will have a common property. The common property of elements will be written within the brackets, within the flower brackets. Let's see the same representation. V is equal to A, E, I, O, U, set of vowels in English alphabet. How we write in set builder form. Here, what is the common property of above elements? They are the vowels in English alphabet. We write it as flower bracket open x such that x such that x we have to write first, and then we write the common property of elements. X such that x is a vowel in English language. So this is what the set builder form of a set. This is another way of representation, and this representation we call it as set builder form. So you should know, if a set builder form it is given, you should know how to list the elements of set within the brackets. That is, you should know how to write it in the roster form. If you know, if it is given in the roster form, you should know what is the common property and you should know how to write it in set builder form. So this is what a brief introduction about the sets. Now let's see some set builder forms and roster forms, how to convert them from set builder form to roster form and roster form to set builder form. Now here we have some one table in which roster form and set builder forms are there. First one, if you see, already roster form is given, you have to write it in set builder form. To write it, you have to know what is the common property of the elements of the set. You can know there 1 is nothing but 1 square, 4 is 2 square, 9 is 3 square, 16 is 4 square, and 25 is 5 square. So here the common property is they are squares of natural numbers. So we can write it in the form a is equal to x such that x we have to write is equal to, it is there in the form n square, like a square number, no? So n square we can write. And what is the condition there? N is 1, 2, 3. N in the place of n, what we have to write? 1, 2, 3, 4, 5. So n is from 1 to 5. So you can write they are natural numbers. So we can write it as n belongs to capital N. That means what it indicates? They are from natural numbers. That symbol indicates belongs. Natural numbers, and till where we have taken natural numbers up to 5. So n is less than or equal to 5. N value should be either 5 or less than or equal to 5. This is what the set builder form of the first set A. Now the second one, set builder form, already it is given. We have to write roster form. Here if you see, the number should be there in the form 1 by n, like 1 by, and the n value should be taken from natural numbers, again from where 1, 2, 3 up to where 6. So it should be there in the form 1 by n, and n values should start from 1 because they are natural numbers, and they must be taken up to 6. This clarity we should have when we write roster form. So here we can write that set in the roster form as b is equal to 1 by 1. 1 by 1 is 1 only, because 1 also we have to take because they are starting from 1. Natural number starts from 1. 1 by 1 is 1. And the second one, 1 by 2, and next 1 by 3, next 1 by 4, 1 by 5, 1 by 6 also. After that we have to close it because we have to take up to 6. So this is what the roster form of the second one. 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6. Hope you all understood. Now the third one, roster form is given. Again we have to write set builder form. We have to identify the common property there. 2, 3, 5, 7. 2, 3, 5, 7 are prime numbers. So all these are prime numbers. So we can write it as C is equal to, C is equal to 1 minute. This also it went 1 by 3, 1 by 4, 1 by 5, 1 by 6. And now C is equal to x such that x is a prime number less than, till where prime number less than 10 you can write, or less than 8 also you can write, because less than 10 we have only 2, 3, 5, 7, you can write like that. X such that x is a prime number less than 10 or prime number less than 8 also you can write. So this is the set builder form of, this is the set builder form of third one. Now let's see set builder form of fourth one. So here one format is given, n square plus 1, and n should be taken minus 1, 0 and 1, because this condition indicates it is from minus 1, 0 and 1. So three numbers we have to substitute in the place of n. So d is equal to, if you substitute minus 1 in the place of n, d is equal to minus 1 if you write, that will be minus 1, let us simplify here, minus 1 whole square plus 1 whole square, which is 1 plus 1, that is 2. So the result is what? Here first element is 2. First element is 2 because we substituted minus 1. Next second element is 0. 0 if you substitute 0 square plus 1 is 0 square plus 1 is 1 only. and third element is 1. If you substitute 1 in that place, again 1 square plus 1, 1 square plus 1 is 2 again. So no need to write second time 2, because already we wrote 2. Again no need to write, so it is just 2 comma 1. This is the set builder form of fourth set, roster form of fourth set. Hope you understood how to write set builder form to roster form and roster form to set builder form. Now let us see some different types of sets. In that first one, null set or void set. What is a null set or void set? A set, null set is nothing but a set which do not contain any elements in it. If a set do not contains any elements in it, we call it as a null set. A set which does not contains any element in it is called a null set. Okay, we denote it by phi. So this symbol. So we also write it as phi is equal to, just open the bracket and close the bracket, empty brackets. This is what about null set. Hope everybody understood. This is very simple. If a set does not contain any element in it, then it will be called as a null set. Then what is singleton set? A set which contains only one element. A set which contains only one element. A set which contains only one element in it is called singleton set. For example, we have set of even prime numbers. In set of even prime numbers, we have only one element, 2, because even prime numbers are only 2. So this can be taken as one example for singleton set. Now we have finite set. If a set contains only finite number of elements, a set which contains only finite number of elements, a set which contains finite number of elements is called finite set. For example, we have seen just now set of vowels in English alphabet, in that only 5 are there. So we can take that as example. So we can write V is equal to A, I, O, U is a finite set, because there are only finite number of elements. Infinite set, very simple. If a set contains infinite number of elements, then that will be called as infinite set. This is very simple. If it contains finite elements, it is finite set. If it contains infinite elements, it is called infinite set. Example, we have natural numbers, whole numbers, prime numbers, even numbers. All these are infinite number of sets only. Example, we can write any example. I am writing set of real numbers. This is an infinite set. Not only this, natural numbers, whole numbers, all these are infinite sets only. And what do you mean by disjoint sets? Disjoint sets means what? Two or more sets do not contain any common elements, then we call them as disjoint sets. If any two sets or two sets do not contain any common element, then they are called disjoint sets. Examples we have even numbers and odd numbers, prime numbers and composite numbers. They are what? Disjoint sets, because if it is even, it is not odd. If it is prime, if it is then it is not composite. Irrational and rational. These all are what? Disjoint sets which do not have any common elements. Next we have subset. What do you mean by subset? Let's take any two sets A comma B. Let's take any two sets A comma B. If every element of A is present in B, if every element of A is present in B, then then A is called subset of B. At the same time, we also call B superset of A, and we denote it as A is subset or equal to B. So this is the uh, representation of A subset to B. Now universal set. What is? Hope you all understood what is subset. Every element of A is there in B. Then we call A subset to B. For example, we have natural number set is subset of whole number set. Okay, that is one example. Universal set. We have to understand it better. Let's see this only. What natural numbers we know, whole numbers we know, integers we know, rational numbers, irrational numbers, and real numbers. Here we know natural numbers is subset of whole numbers, and whole numbers is subset of integers. Integers are subset of rational numbers. Not irrational numbers, rational numbers, and rational numbers are subset of real numbers. We also know irrational numbers are also subset of real numbers. So here this R real number set is superset of all these sets. So we call here R is universal set. Universal set of all these sets. What? Natural numbers, whole numbers, integers, rationals, irrationals. So whenever some sets are given, the biggest or superset of all the given sets will be called as a universal set. Okay, among all the sets, whatever set is bigger or superset of all the given sets will be called as a universal set. Remember it. Okay, this is enough today. We'll discuss Venn diagram representation and cardinal number of a set and some other important concepts in this topic in the next class. Hope you all understood this topic up to here. Thank you.